Welcome to The Elements, a visual exploration of every known atom in the universe. We'll start off our exploration with gallium. Now, mercury is often cited as the only liquid metal at room temperature, and that is sort of true. Normally, though. However, if it was in different places, such as, let's say, somewhere in the tropics, gallium and cesium would be on the list too of metals that are liquids at room temperature. That's mainly because gallium melts at a slightly higher than average room temperature. If you pop some gallium into your mouth, not with some protection, of course, you have to wrap it in some plastic wrap before you put some gallium in your mouth, it would melt. And since it would melt, well, it will probably go ahead and turn into this kind of liquid. Even in Alaska, gallium itself would melt literally in your hand, also it would take a few more seconds. This, however, you'll probably not be able to relieve yourself. If you go ahead, it's known that gallium is not toxic. It's at least known it's not toxic. However, it does have a tendency to go ahead and stain your skin brown, and you can always just play with it in a plastic bag. And because of its low melting point, it's kind of useful, and it finds a practical application in apparently this alloy that has been patented. It's called gallium. This is for gallium. And this is for indium, and this is stannum, which is apparently the Latin name for tin. Nowadays, if you go ahead and you buy a fever thermometer that looks like it contains mercury, it probably contains gallium instead, because mercury has been banned in that application for years. However, gallium's most important modern use is in semiconductor crystals. Silicon microchips, semiconductors, usually will stop working at a few gigahertz, but well, gallium semiconductors will go ahead and it might last even like 250 gigahertz, which is upper end of the microwave frequency range. It is also present in nearly a lot of LEDs, like nearly all of them. Its atomic weight is 69.723, its density is 5.904, its atomic radius is 136 picometers. It has a kind of cuboid structure. It has a pretty, well, very, very low, I should mention, very low atomic emission spectrum. And it has just barely passed the 4 S's. As mentioned earlier, it has a very, very low melting point. And because of that, well, it kind of has a higher boiling point, at least. Next up, we have germanium. Germanium itself, as you probably guessed it, is the English name. It bears the name of the modern name's English country of Germany. Germany. And germanium is the only element that is stable and very common, at least among elements that have names of countries. If you compare it to americium, francium, or apparently polonium, they are all radioactive, and they were discovered much later, and they were not found in nature, so they're not very applicable to any degree. When Dmitry Mendeleev went ahead and created his periodic table in the ways that we know today, he bravely left some gaps into it, like gaps here into it, into places that he thought that elements were not discovered yet. One of them, he proposed some of its properties, and then 20 years later, when the properties of his element was found, he was all like, "Hey, yeah, we found germanium," and it was almost right, except it wasn't almost right. It was like a little bit off, and so Dmitry Mendeleev was, "No, it has these properties." Such again, and then finally, after a bit more searching, apparently Mendeleev was right. There was a more isotoped version of germanium, and since it's in part of the semiconductors list, it's also used in semiconductors, and because it's used in semiconductors, it is really useful in that sense too. Well, silicon transistors, still superior to germanium ones, are still used. Germanium ones work at the lower purity levels of the 20th century, unlike the silicon one, which really requires pure metals or pure substances to work out effectively. Nowadays, though, they are still used in the semiconductor business, but they're mostly used in fiber optics. It has a sort of wonky cube structure. Its atomic weight is 72.64, its density is 5.323, its atomic radius, it's about 125 picometers, very balanced. And it just barely started going into the 4Ps. It has a pretty high melting point. It has a pretty high boiling point as well too. Next up, we have arsenic. Beware of this shiny metal. You might think it's beautiful. Obviously, it is not beautiful. It is very poisonous. Arsenic, or Paris green, which was used inside of it. Paris green literally had arsenic inside of it, and nowadays we find out that it has poison in it. Well, it's one of the few it was one of the few chemicals that was part of an artist's pigment and as a rat poison. For some reason, people use arsenic in like greens, even though they knew it was poisonous. Given how strong arsenic is associated with poison, it may come as a surprise that it was intentionally added to feed chickens. Yes, feed chickens raised for human consumption. That's very surprising. Apparently, organic arsenic is less toxic than pure arsenic, and it promotes the growth of chickens. There is some research that even suggests that needs to be a low amount of arsenic for chickens to grow properly, unlike humans. Possibly even in humans we need a little bit of arsenic. Also, not too much, that will be an overdose kill. It was even used as a pigment in Paris green, which is basically emerald green, and that was very popular at the time. In fact, one of the most famous English guys went ahead and said, "I promote Paris green. I'd rather use Paris green than synthetic paints. It's better, it looks better, and it is safe." One bad thing about England, though, it rains a lot, so it's damp always. And when it's damp, mold grows onto wallpaper. And when wallpaper gets converted into a gas form. And you do not want to know arsenic in its gas form. Lots of people died because of arsenic poisoning from the wallpaper. And eventually, Paris green was banned. Most people, though, didn't realize this because they had this superstition, and this was always the case, that, hey, damp weather is always bad. Is it damp weather that makes us bad, or green wallpaper that makes us bad? Well, if you move to a place in a dry climate with green wallpaper, that's Paris green, but very dry, well, then you suddenly feel fine. Unaware of the latter possibility, that maybe the water vapor has arsenic in it, people at the time naturally concluded that it was no damp weather. I mean, who's going to argue with the doctor ordering you to go to the beach for a few months? The atomic weight is 74.92160. Its density is 5.727. Its atomic radius is 114 picometers. It has an oblong cube structure. It has a really, really low boiling point. It probably just sublimates into gas. And it started to go into the middle of the 4Ps. Next up, we have selenium. Selenium is famous for being part of nuts. Selenium is an essential nutrient in small amounts, but too much of it is toxic. That's why eating too many nuts is terrible for you kids. This is also true for other elements, but in selenium's case, everyone experiences it. Plants, animals, humans, we all experience it. We always suffer from too little of it or too much of it, depending on where you're living, and in the plant's case, how much selenium is inside the soil. Selenium glaze gives a red color, apparently, and selenium, when you mix it with sulfur, you get selenium sulfide, and you can create shampoo with it. You can find lots of it in nuts, especially Brazil nuts. They are famous for having their selenium content really high. Its atomic weight is 78.96, its density is 4.819, its atomic radius is 103 picometers, its crystal structure, it's a hexagonal prism, and has a really, really low, really low melting temperature, and has a really, really low boiling temperature. It has a pretty varied amount of its atomic emission spectrum, and it started to climb up the 4Ps. Next up, we have bromine. And exactly two elements in the periodic table are stable at room temperature. The first one, it's mercury. The second one, it's bromine. Technically, the first one is bromine because it comes first in the periodic table, but I like to call mercury first because it's the most famous one. Now, mercury is a firmly liquid. It melts at like negative 37.8 degrees Fahrenheit, and it does not boil until like 675 degrees Fahrenheit too. Bromine's boiling point is just 138 degrees Fahrenheit, which is about 59 degrees Celsius, meaning that it's barely still a liquid at room temperature. It's barely a liquid. And so close to boiling temperature it is when it is at room temperature that if you leave it there for a minute and let the heat accumulate, it will turn into a cloud of red vapor in just less than a minute. Mercury, well, it evaporates too, and that's why it's so poisonous and banned. Just like other halogen gases, it spends most of its time as an ion. You can find them in ionic salts or, if you're lucky enough, in some hot tubs. Even some bromine is added towards children's pajamas, mainly because it is required by law. There is an alternative though, you can always just go ahead and get some cotton on it. Bromine itself, it's treated with tetrabromophiphenyl A, and that's put inside children's pajamas for certain reasons. Although a little imagination goes ahead and might even deter people from criticizing it, mainly because you'd rather have someone going ahead wearing those protected PJs instead of, let's say, burning children. It has an atomic weight of 79.904, its density is 3.120, its atomic radius is 94 picometers. Look at that, it's beautiful. Its crystal structure, it's a cuboid, very stable in my opinion. It has a nicely varied atomic emission spectrum, and it has finally almost filled the 4 Ps, which I really hope we'll see it filled in the next video. I hope you guys enjoyed this episode. I hope to see you guys soon. Until next time, Shlan out. Peace. Bye bye.